We're going to start our forces unit just with a definition of a force. So a force is a push, pull, right? And the symbol for it is going to be F, the unit. Now, Newton's first law, maybe you've heard this before, I'm going to put it maybe in slightly different words. Okay? An object in motion will stay in motion. I'm going to add something at a constant velocity unless acted by an unbalanced force. Now, for the section here that says what this means, we're going to divide it into two parts. On the left side, we're going to say if force is balanced, okay, the object has a constant velocity. And remember, velocity means both speed and direction. It may be at rest. So if force is all balanced and an object is moving at 30 meters per second east, it has to stay moving at 30 meters per second east forever and ever until the forces don't balance on it. We tend to think force is balanced means at rest. It actually doesn't. It means that it is a constant velocity. Okay, now if they don't balance, okay, there is a change in velocity. It could be speed and or direction. And another word for a change in velocity is an acceleration. So I'm going to draw a couple diagrams here. Let's say I have an object A. I'm going to put four forces on one head. One is 4 newtons. Two is 8 newtons. 3 is 4 newtons. 4 is 8 newtons. Okay? Now, the forces are all balancing, so the object must be at constant speed or constant velocity, since the force is balanced. Now, we don't really know anything about that constant velocity. It could be moving right, down, okay, or at rest, because the force is balanced. Now, if I draw the same object or a similar object, call it G, then we're going to have force 1 is 4 newtons, force 2 is 8 newtons, force 3 is 4 newtons. Instead of 4, it is 11 newtons. Okay. My unbalanced net force is equal to. So in this case, the 4 and the 4 up and down are going to cancel each other. I have 11 left and 8 to the right. The unbalanced part, 8 of that 11 is balanced by 8 on the other side. But 3 of it is not balanced, not against them. So the unbalanced net force is 3 newtons to the left. So now we know that it is not constant, or not constant velocity. Now there's a number of things that could be happening. It could be moving left. And this 3 newtons pushing it left, so that would make it speed up. Okay. It could be moving right. And if it's moving right, but this 3 newtons is pushing it left, that's going to make it slow down. Or it could be moving up, but then it's going to curve left. Okay? So any of these 3 things are what it could be doing. So, top of the next page, and we're going to mention something called inertia. All right, so I'm going to pick 2 things. I'm going to have a little Volkswagen Beetle. Even if I put a force on it, okay, it's an unbalanced force, so what's going to happen? It will accelerate. Now, let's, instead of doing that, put a big giant tank truck. Alright, and I put the same force on it. This will also accelerate. Which accelerates more? Okay, so which one is going to be easier to push and have it speed up? Turns out the Beetle is going to speed up a lot more than the truck will. Okay. So why? Okay, we're going to start talking about inertia. Inertia is a resistance to a change in speed. Okay, so which resists the change in speed more? It turns out the truck does. Now, you may have figured that out, quite a little bit ago, because the truck is a lot bigger, it has a lot more mass, it's going to be harder to move, okay? It has more mass. So inertia equals mass. Something with more mass is more inertia. Something with more inertia is harder to get to accelerate.